Question 20. The max speed of an airplane, 200 kilometers an hour. Find the max speed which you can travel due north. So the plane is going in this direction. If there is a northeast wind, now that's not north of east, I think it tells you northeast wind is from the northeast, so it's coming from up in this direction and it's traveling down in that direction. So the velocity of the wind here is negative. It's going down into that double negative. So the velocity of the wind is 50, and it's going to be cos 45 and sine 45, so it's minus 50 cos 45 in the I direction, minus 50 sine 45 in the J direction. We decimalize down, we're going to get minus 35.355 minus 35.355, both in the I and J directions, for the velocity of my wind. So the plane needs to fly due north. It's going to have to fly in this direction to go this way, and the velocity of my wind is coming down in this direction here. So this is my diagram. It looks something like this. The velocity of the airplane relative to the wind. We have the velocity of the wind. We have the velocity of the airplane traveling due north. So let's call this the angle A. So the velocity of the airplane relative to the wind, it can travel 200, the max speed, so it's 200 cos A in the I direction, and it's going positive plus 200 sine A in the J direction. The velocity of the airplane is the velocity of the airplane relative to the wind plus the velocity of the wind. So that's going to give me 200 cos A and minus 35.355, 200 cos A minus 35.355 in the I direction, plus 200 sine A. And the same again, minus 35.355 in the J direction. And because we're looking at due north, there's no I component, so this has to be equal to 0. So we can say that 200 cos A equals 35.355. Cos A is equal to 35.355 over 200. And the inverse cos of that will give me A. So A is equal to 79 degrees and 49 minutes. So that's the angle. What were we asked for? We were asked for the max speed. Find the max speed it can travel due north. Okay. So we're going to have just this component here. So we're going to have 200 sine 79 degrees, 49 minutes, minus 35.355 in the J direction. And dealing that into a calculator, that is going to give me 161.5 kilometers an hour. It's the max speed of a traveling due north. Okay, question 21. So a ship can sail 10 meters per second in still water, has to go from A to B and back again, and the current flows at 5I minus 6, so positive negative in that direction. So this ship is going to need to go in this direction to get back down to the I component, and it can go at 10. We have an angle A, and 5I minus 6J is the velocity of the current. So the velocity of the current, 5I minus 6j. The velocity of the boat, or let's call it ship here, the ship relative to the current, is going to be 10 cos A in the I direction, positive here, plus 10 sine I in the J direction. So the velocity of the ship is the velocity of the ship relative to the current plus the velocity of the current, which in this case is going to be 10 cos A plus 5. And we've no J component here in the I direction, and it's going to be plus 10 sine A minus 6 in the J direction. And because the J component is equal to 0, we can say that 10 sine A is equal to 6. So the sine of A is 6 over 10, which would give me that 6, 8, 10 triangle. Just do a little sketch real quick. A opposite hypotenuse adjacent. So the cos of A is equal to 8 over 10. What do we ask for? The time taken to complete the journey. So let's get the velocity of the ship. Get the speed here. So 10 cos A, 10 by 8 over 10 plus 5 in the I direction, plus 0 in the J direction. So we're going to get 10 plus 5 is 15. 8 plus 5, 13. Velocity of ship is going to be 13 in the I direction. We also know that it's 195 has to go again back again, complete the whole journey. So this is going to be 195 divided by 13, which is 15 seconds to go from A to B. So returning the velocity of the ship, let's do it here. So returning the velocity of the ship is going to go, it's going to go in this negative I direction. So it's going to be minus 10 cos A plus the 5 in the I direction. And we're going to get the same J direction, plus 10 sine A minus 6 in the J direction. That's still going to give me sine A is equal to 6 over 10. So yeah, it's the same angle, going to give me cos A is equal to 8 over 10. So the velocity of the ship on the way back is minus 10 cos A plus 5. So we're just going to have a negative 10 instead of a positive. So that's going to give me negative 8 plus 5 is equal to minus 3 I, and it's 195 divided by 3, 65 seconds on the way back, 15 on the way out. So the total time taken here is 80 seconds. There's another part here. Faster ship can go to from A to B in 13. How long will it take to go from B to A? Okay, so if the faster ship can do it in 13 seconds, it's 195 divided by 13. So that is going to give 15 meters a second for the speed. And we can see what happened here with this minus 3. The difference between this one and this one, it changes by 10. The change in the I becoming a negative 10. So the outward return speed must be 5 meters per second. So 195 divided by my 5 is going to give me 39 seconds. So I have 13. What's the question asked me? How long will it take to go from B to A? Okay, we have it there. We have our 39 seconds.